Okay, let's talk about vertical position. The oscilloscope shows us what's happening in our circuit. It doesn't modify that in any way. Each channel will have an arrow on the left side of the screen and a number. In this case, that's channel 1, and that's telling us that's the 0 voltage point at channel 1. That's where the probe tip voltage and the ground clip voltage are the same. We can set that point anywhere on the screen. We can set it from the top of the screen to the bottom. We can even move it off the screen. In general, you should never move it off the screen because then you no longer know where 0 voltage is. If you've got an input signal, here's an input signal. Right now I have a 5 volt. Let's go to a 1 kilohertz input. It's a 1 kilohertz sine wave. I'm going to make that amplitude 1 volt peak to peak. So now it's 1 volt peak to peak. And I'm going to add an offset to it. Let's add a 4 volt offset. Well, the first thing is when I have a positive offset on a signal, or if I have a signal that only goes from 0 to some positive value, it makes no sense to have my 0 voltage in the middle of the screen. The bottom half of the screen can never possibly be used. Why waste half our real estate? So I normally set my 0 point at the first division above the bottom of the screen if I know that my signal can never go negative. Now, notice that my signal isn't triggering because my trigger level is in the wrong place. So I'll hit my set to 50%. So now I've got a signal that is 1 volt peak to peak, and it's got an offset of 1, 2, 3, looks like 4 volts. Now suppose I want to zoom in on that signal. What happened? Well, this little arrow here tells you that the signal is off screen somewhere. What you should not do is bring it back by moving the 0 point off screen. That's a bad idea. What we want to do is get rid of the DC offset. We can do that by going from DC coupling, which means that the scope is showing us both the AC signal and any DC that's on top of it, and selecting AC coupling. When we do that, the DC value is thrown out. Now it makes sense to have our 0 point in the middle of the screen. Once again, I hit the set to 50% to trigger, and I can increase my vertical gain to use as much of the screen as possible. Now, it's important to understand that you are not seeing the entire signal when you're in AC mode if there's a DC offset. This looks like this is the 0 value of this waveform. It's not. There's a 4 volt DC value that's been added to that waveform, and we've thrown it away with the AC setting. So in general, when you're done using AC, I strongly suggest you put it back to DC. Our signal's now off screen. We can bring it back in. We can cause it to trigger. And now we can see that we've got a signal that's got some sort of offset to it. Once again, if I know I can't have a negative value, I want to use as much of the screen as possible. And here we've got 1, 2, 3, 4 volts of DC signal and approximately 2 volts peak to peak of AC signal. So make sure you understand DC coupling and AC coupling, and do not use the vertical position to try to bring a signal that has a lot of DC from off screen onto screen, because you lose your position. It's also possible that the input amplifier can't handle that big a DC value that's internal to the oscilloscope, and in that case you may get false results, or at least incorrect results.